Hi everyone, we're going to continue with the index laws today. We're going to review them a little more and just do a whole bunch of new examples. Okay, so I've placed here on the left hand side all the laws that you are responsible for. You should have these laws with you all the time as you are solving your problems, because what you're going to encounter now is not just using one of the single laws for every problem, but you may have to use several laws for one problem in order to simplify. So it's good to keep them close by. Alright, so if I'm looking at the first example, so we're just going to start with our first example here. And if we're going to start with the first example, well, what you should automatically realize is that basically if I've got 2a cubed all squared, if I were to expand that, really that means 2a cubed times 2a cubed. Now, in the expansion process here, then all I would have to do then is just multiply together all my numbers, and then wherever I have the same bases, because it's multiplication, then I would add the bases. So that this would go to 2 times 2 will give me 4, and then a cubed times a cubed means that I have a to the 3 plus 3. I'm just going to put that in there, but it's obviously not necessary, which will go to then 4a to the 6th. Now, keep in mind, and that was using the first law here, that we have a to the m times a to the n equals a to the m plus n. Now, the alternative way of looking at the problem would be to just use our third law, which was a to the m times all to the raised to the power of n, which means that I just take everything that's inside the parentheses and it's going to get raised to the power of 2. So I'm really doing 2 cubed times a cubed squared, 3 times 2, so that it goes to 4a to the 6th. We obviously get exactly the same answer. We're just going about it using a different law. Okay. Our second example, again, is another problem where we are looking at either expanding it just by saying that negative 2x times negative 2x, so I could say negative 2x times negative 2x times negative 2x. Now, a negative times a negative will go to a positive, times another negative will go to a negative, so that you'll have negative 8, and then x times x times x. Well, that's like saying x to the 1 power to the power of 1 to the power of 1, so it's 1 plus 1 plus 1, which would give me negative 8x cubed. Again, if I had just used the laws of the exponents, I am most likely to have done negative 2 cubed times x to the power of 1 all cubed, and that would have given me, very simply, negative 8x cubed, which again is exactly the same answer as we got in the first part. Alright, so we're going to look at, again, a couple of other examples that are quite similar, and we're just going to use the short form here. So we're going to do, it's 5 squared, so it's a power to a power, so 5 squared will give me 25 times y to the 4th squared, and that gives me an answer of 25y to the 8th. If I now use the next one, if I complete the next one, then it's like me saying here we've got 3 cubed times 3x times x cubed, and that gives us, again, it's a power to a power, so 3 cubed is going to be equal to 27, and we have 27x to the power of 9. Now, the next problem, we've got 2x to the 4th times 3x cubed, so I will multiply my numbers together, so 2 times 3 will give me 6, and x to the 4th times x cubed, because we've got the same bases, we're going to add our exponents together, so it will go to x to the power of 7. Okay, so that's a series of examples. Let's look at a few more. Again, these are quite simple, they're not that complicated, but they do allow you to use, in some cases, more than one of the laws at the same time. So, for my next problem, I've got 4x to the negative 2 times 2x cubed, so 4 times 2 will give us 8, and x to the negative 2 times x cubed, well, that's like saying to x to the negative 2, or negative 2 plus 3, which gives me negative 2 plus 3. So I'm just putting it in there to show it to you, but you wouldn't necessarily do this step here. It would be 8x to the power of 1, which is nothing more than 8x. If I look at 5a to the power of negative 2 times 6a to the negative 3, well, I have 5 times 6 is going to be 30, and then a to the negative 2 times a to the negative 3 is going to give me a to the negative 5. Now, we never leave our answers with negative exponents, so here we're going to take this one step further and use another law, and this law was the one where we have the negatives in the exponents. And so if I have a negative in the exponent, the way in which I am going to change that into a positive exponent is by taking the reciprocal of it. So I will go as 1 over a to the power of n. So my a to the negative 5, in order to make it positive, will go down to a denominator, so that my final answer will go to 30 over a to the 5th. So this was really like saying 30 times 1 over a to the 5th, and that gives me 30 over a to the 5th. Just be aware, please, that the 30 does not go down in the denominator. The only term that has that negative 5 power is the a. It is not the 30. So the 30 will remain up in the numerator, and a to the negative 5th will go down to the denominator in order to go to a positive. Alright, if we take a look at the next example has 2, and now we've got only 3x squared raised to the power of 3. So everything inside the parentheses will change, will be raised to the power of 3. So 3 cubed will give me 27, and then we have x squared cubed will give me x to the power of 6. And then my final answer is going to be 2 times 27, and 2 times 27 is 54, and then that's just multiplied by x to the power of 6. If I look again at the next one, very similar to number 8, the previous one. So we have 4 times 3 squared is 9, m cubed squared will give me m to the power of 6. I now multiply 4 times 9, which gives me 36 m to the power of 6. And the last one down here on this page, we have 4x cubed times 5x to the 6th, so that should come quite obvious as 20x to the power of 9. Alright, now as we proceed, the problems are going to get somewhat more difficult. So let's take a look at some other examples of questions that are a bit more challenging. And some of those questions are, so for example, we've got this next one here. So we've got 2x to the 3rd, 8x to the 5th. So we can actually start simplifying or multiplying our numerator together, everything that's up in the numerator, so that 2 times 8 will give me 16, and x cubed times x to the 5th will give me x to the 8th. And that will be all divided by 4x to the 6th. Now, because we are told to simplify in these problems, simplify means we want to place it in the most simple form as possible, so that if I now look at 16 divided by 4, well, 16 divided by 4 will give me 4. Now, because I've got x to the 8th divided by x to the 6th, that's really like saying x to the 8 minus 6. And again, it's not a step that I necessarily am going to be placing in there. I'm just putting in there to show it to you. But it would be 8 minus 6, which gives me x squared. So my final answer is 4x squared. Now, in number 12, we've got everything in the first parentheses that's raised to the power of 3. Everything in the second parentheses is raised to the power of 2. So I will say 2 cubed is equal to 8. A squared cubed will give me a to the power of 6. And that will be multiplied by 4 squared, which is 16. And then we will have a to the power of 6 again. Now, if I take a look now at my powers, let's look at our powers first. A to the 6th times a to the 6th really gives me a to the power of 12. And then if I now do 8 times 16, that should give me 128. Okay, the next one, question 13. Now, question 13 gets a bit more challenging because now we've got not only positive exponents, but we also have negatives as exponents as well. And remember, our final answers must be always in terms of positive exponents. So I can work the problem out as if I can work the problem out with the negative exponents in it, just as long as at the end that negative exponent is then converted into a positive. Okay, so if I have, again, a to the negative 4 y cubed, all raised to the power of 5, that means that everything inside that parentheses is going to be multiplied. So it's going to be a power to a power. So this will go to a to the negative 20, negative 4 times 5. That's where I got the negative 20 from. And then y to the 15th. And that all gets divided by a y to the negative 5. Now, there are several things that I can do here now. I'm going to show you a couple of ways I could solve this now. So the first way I could solve this problem now is by simply saying, well, if I now divide and I say a to the negative 20 divided by, so I could divided by a to the power of 1, and then I have y to the 15th divided by y to the negative 5. Well, this could really be rewritten as a to the negative 20 minus 1, and then it would be y to the 15th minus negative 5, because we have division in between these. So it's minus 20 minus 1, and then 15 minus 5. So that this would go to a final answer of a to the negative 21, y to the 20th. Now, because I said that we cannot have, or we should not have, negative exponents, then I will use again my law of a to the negative n is equal to 1 over a to the n. So wherever I have a negative exponent, if it's in the numerator, because remember this is like saying, the problem is really saying a to the negative 21 y to the 20th over 1. So what I will do is I can take this a to the negative 21 and just bring it down to the denominator in order to make it positive. So it'll become a to the power of 21, and that'll still be over whatever was in the numerator that was positive, which was y to the 20th. So my final answer is going to be simply y to the 20th over a to the power of 21. Now, that's my first way of dealing with the problem. The second way of dealing with the problem is what I could have done was I could have automatically have switched from this step here, so the one that I'm circling right now, I could have automatically switched the a to the negative 20 down to the bottom, so bringing it down to the denominator, and I could have taken the y to the negative 5th, which was in the denominator, and I could have brought it up to the numerator. And I'm using the law that says if I have a over b to the power of negative n, well, I can make both of those positive by bringing b up to the top, and it becomes to the n, and a will go down to the bottom so that it goes to a positive as well. So basically, the law says a over b to the power of negative n will go to b to the a over to raised to the power of n. So just to give a very quick aside here, if I had x to the negative 3 and y to the negative 5 over y to the negative 5, I could make both of these go positive by switching their positions, so that y to the negative 5th will go up to the top as y to the 5th, and x to the negative 3 will go down to the bottom as x to the 3rd. So that's what I'm going to do right now here. I'm going to take the y to the negative 5, and I'm going to bring it up to the top, so it becomes y to the 5th, y to the 15th, over, and the a to the negative 20 is going to go down as a to the 20 times a to the power of 1. And there I have my answer now. All I need to do is multiply my numerators. I need to multiply my denominators, and I am done. And multiplication here I intend as adding my exponents because I've got the same bases. Therefore, with the multiplication process, I'm going to add the exponents so that I have y to the 20th over a to the 21st. And that's exactly the same answer as I had in the first method that I used. I tend to prefer using the second method where I switch my negatives up to the top. If they are negative in the bottom, I bring them up to the top. If they're negative up in the top, I bring them down to the bottom to make them positive. Okay, so we're going to look at one more problem that is on this page, and I'm going to erase part of this so that you'll be able to see the rest of this problem. Let's see if I can move this up a little bit. Layer 1. Okay, so I'll move this up a teeny bit. Alright, so let's see how far we can get here. Let's see how far we can get. Okay. Okay, so in this third example then, what we can do is we can take a look at how to simplify this. Now there are many ways that we could simplify this problem. I'm going to use one approach, but there could be different ways of approaching it. So I'm going to start by simplifying, where possible, the first fraction, so that I have 5 over 4, and then x cubed divided by x to the power of 1 will give me x squared up at the top, and y to the 4th divided by y cubed will give me y to the power of 1 up at the top, or just y. Now, because it's being multiplied, now notice that it's being multiplied by all of this fraction. Now the top part has a negative, the numerator has a negative exponent, and the denominator has a negative exponent. So in order to make my life a little bit easier, what I'm going to do is I'm going to flip the positions of the two. So I can say 2xy, and now it goes to the power of 2 if it's brought up, and it's divided by 25x to the 4th y, all to the power of 1, which really isn't necessary to write to the power of -1, so that I will just leave it as 25x to the 4th y. Alright, so now the next thing I want to do is I want to simplify my right-hand side here, because I still have a power to a power going on in the numerator of the second fraction. So that I have 5x squared y all over 4, and that's multiplied by everything is raised to the power of 2 inside that parentheses. So it goes to 4x squared y squared, and that's all over 25x to the 4th y. Now, what I can do from there is I can do several things. Now, what I tend to do is wherever I can cross-cancel, I will cross-cancel to make my life easier. So I can say, well, 4 will go into 4 once, 4 will go into 4 once, so I know my 4's are gone, and 5 will go into 5 once, and 5 goes into 25 5 times. Now, I have a choice of either cross-canceling, or what I can do is I can actually just multiply now everything that's in the numerators together, and then multiply everything that's in the denominators together, and then I can simplify from there. That's what I prefer to do at this point. So that I'm going to say I've got x squared times x squared gives me x to the power of 4, and y to the power of 1 times y squared will give me y cubed, and that's all divided by, now I've got 1 times 5 is 5 down here, so let's not forget there's a 5 down in the denominator. And then I just have x to the 4th y. Now, the x to the 4th and the x to the 4th found in the numerator and the denominator cancel themselves out. So it's like saying 2 over 2 or 5 over 5 or x over x. So we cancel those out, and all I'm left with is, at this point, is a y cubed over 5y, which when I simplify that now further, so it's in the last step, when it gets simplified further, it's going to become y cubed divided by y to the power of 1, remember, so it goes to 3 minus 1, which is y squared, and y squared is a positive, so I don't need to bring it in the denominator, it just stays in the numerator, and it's y squared over 5. So that's my final answer. Okay, my next example is a little bit more difficult, and then we're almost done. We've only got a couple of more examples to go here, a few. So let's take a look at the first one now. We've got a fraction, and we've got a power to a power. So I'm going to do 3 to the power of 4, and I'm going to do the long version of this. So I'll do 3 to the power of 4 times a to the power of 20 all over b to the 4th c to the negative 4. So I brought everything raised to the power of whatever the power was. So b to the 4th and c to the negative 4. And now that gets multiplied by, now I'm going to use that trick that I said before, a over b to the power of negative n will go to b over a to the n. So wherever there's a negative in the numerator, a negative exponent, I will bring it down to the bottom to make it positive. And wherever there's a negative exponent in the denominator, I will bring it up to the numerator to make it positive. So I'm going to take the c to the negative 1 and bring it up to the top. I'll bring that up to the top. And the a to the negative 4, I will bring down to the bottom to turn it into a to the 4th. So that this is going to become 9c to the power of 1 b all over 2a to the 4th. Okay, so everything is now in its positive form, at least in the second fraction. It's all in the positive. And I'm going to take a look now at the next one. So the next one, the one on the left, rather, the fraction on the left. And what I'm going to do now is I'm going to take that c to the negative 4 and I'm going to bring it up to the top. So it becomes 3 to the 4th, a to the 20th, c to the 4th, all over b to the 4th. And that gets multiplied by 9c, b, or bc, over 2a to the 4th. Alright, so again, I can simply just multiply across here so that I can say, well, 3 to the 4th is really like saying 81, and it'll be a to the 20th, and then c to the 4th times c to the 1 gives me c to the 5th, and that b to the 1 just stays up at the top. And that gets divided by 2 times a to the 4th, b to the 4th. And my last step here is going to be now to divide all my variables, all the exponents on the variables, so that I have a simplified version. Now I've just caught here that I have 3 to the 4th, which gave me 81, but I also had a 9 here, so that it's times 9. So it should go to 81 times 9, which gives me 729 a to the 20th, c to the 5th, b, all over 2 times a to the 4th, b to the 4th. So now, my final answer should be 729 over 2, and now we're going to simplify. a to the 20th divided by a to the 4th gives me a to the 16, so it will stay up at the top. And then I will stay with a c to the 5th up at the top because there is no other c. There's just c to the 5th. And now, here's the part that needs to be clearly understood, is that I have to subtract my b's because I'm looking at the division. So it's b to the power of 1 divided by b to the power of 4, and that really gives me b to the 1 minus 4, which is equal to b to the negative 3rd. Now, to the negative 3. b to the negative 3 is going to belong on the bottom, so it shall go to a positive. So it will go to a b to the third. Now, the last couple of questions, we've got a few more here. Here you're being asked in questions 16 through to 18, you're being asked to evaluate so that you have 3/4 raised to the power of -3. So evaluate means you're going to get an actual answer in the end. So I'm going to flip these around so that I will get 4/3 cubed, because that was the power of -3, and that's times 2/9. So 4 to the power of 3 is going to be 64, and that will go all over 27, and that will be multiplied by 2/9. So now when I look at 64 times 2, that gives me 128, and then as I do 27 times 9, I end up with 243. Okay. We might be able to simplify that further. Let's see. And I don't think there are any numbers here, so the answer is no. You can't simplify that any further. All right, our next problem. Now again, we're going to flip these around because we've got a power to the -2, and we've got the fraction, so we can change it to 3/5 all squared divided by 25. Now we're going to change this to 9/25. Now because it's divided by 25, that means that I'm going to flip it around. 25 is like saying 25/1, which means that when I am doing the division of with a fraction, then it's going to go times 1/25, so that I end up getting 9/25 times 25, which is 625. So my final answer here is 9/625. Now, the last example that we have is where we have 0.2. Now 0.2 can be written to, and it's raised to the power of -2. 0.2 we could rewrite as a fraction, so I can rewrite that as 2/10, and that's raised to the power of -2. And that gets divided by 5 to the 0. 5 to the 0 is like saying 1, and that gets multiplied by 5 to the -1, which is 1/5. Now we are going to do this, the order of operations is going to be multiplication and division in the order in which they are found, what comes first. So 2/10 is like saying 10/2 squared. Now that's going to be divided by 1, which is just going to be whatever the answer is here, 100/4. And that will get multiplied by 1/5, because of it, 100 divided by 4, 100/4 divided by 1 is just 100/4, and that gets multiplied by 1/5. So that I end up getting, if I want, I can cross multiply, I can cross cancel, but what I'm going to simply do is just say 100/20, which gives me nothing more than 5. So my final answer is 5. All right. So the classwork you'll be working on in the next class we have is going to be a handout called Indices and Standard Form, and it'll be found on Google Drive, and you will be responsible in class to complete questions 1 through to 60, 119, and 121. There's quite a number of questions there, so there's a lot to do. See you next time.